Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro, here to tell you about 3i Atlas, what it is doing as far as we know. There's been a lot of discussion about 3i Atlas for many months now. The latest thing is that someone supposedly put in a Freedom of Information request with the United States government, CIA, and they replied back that they can neither confirm nor deny that they have documents on 3i Atlas. So a lot of people are running with that story. This is classic intelligence stuff where they just try to mindfuck you. So you just got to ignore that stuff in general because they're always going to do this from a position of power of, whoa, we don't know. Maybe we're checking this thing out. Just if they're not truthful people to begin with, you don't pay attention. That's at least my mindset. So I'm aware, but I'm also not. It's nothing really to look into because it's a distraction from the real dynamics at play with this interstellar object, which has been blasting plasma and dust all across our solar system now for many, many months. It showed anomalous activity when it was first picked up. And then we looked back in the record, going back to, I think, like May, even April, and we saw that it was showing signs of off-gassing already, even at distances that typically we don't see comets doing that with. There's other comets, solar system comets that have done that. But in terms of, it's not common. And then, of course, it has this forward-facing tail, the sunward-facing tail, that has existed both pre-perihelion, its closest approach to the sun, and also post. So it's been there effectively moving after it did its fast swing by around the sun. And as we can see with these images here, which some of you may have seen at this point, it has done a tremendous amount of gas, plasma, and dust dispersal through these jets that it has been emanating. And many, many, many amateur astronomers have imaged these jets in a variety of ways. And there's a changing structure to them. We also know that 3i Atlas is rotating about 15, 16 hours or so. That's our best data. We should roll with that until something better comes along. But we know that it has these jets. And so that's common activity. It's not like we've never seen this before. The forward sunward facing tail is a little odd, but it's not exceptionally bizarre like some people are making it out to be. But you put all of it together, and effectively what's happened is a tremendous amount of dust and gas and plasma has been emitted from 3i Atlas. We have historic examples of when Earth passed through the jet stream or the dust tail of comets and of meteor jet streams and more. And well, it can be pretty dramatic. We can really have some incredible moments. For example, 1833, there was a meteor storm which was reaching rates of over 250,000 per hour. So people thought it was the end. I reworked the original graphic from back then to be more modern in time, but the people were flooding into churches. They were praying, their God save us. Because, if you were to see 250, 300, 400,000 of these things coming down every hour, right? It's not just one, and then two, and then three. It's like a non-stop stream. You're probably thinking the world is ending. This has happened before. This is 1833. The common explanation is that this is from the Leonids meteor stream. And there's a comet that's part of that, which does close passes to the Earth every now and then. It gets really close to Earth's orbit. This is specifically 55P Tempel-Tuttle, so you can research into that if you want. But it is bizarre, and we technically don't know what it's from. The math checks out, but it is possible that some other factor was a part of this, because what's bizarre is that these meteors in 1833 were coming straight down. All the graphic representation showing them come straight down. If you would have a comet flying by or its dust stream going by, you'd expect them to come in at an angle. And so, they're not coming in at an angle. So maybe something exploded directly above the Earth and it went down that way. And the other comet swinging by perhaps is implicated in that. There's a lot of different ideas out there that you can explore, that others have explored, to explain the observational evidence of what we saw, which is extremely high counts going to the hundreds of thousands, and these particles from space going basically straight down. So this all matters because we have 3i Atlas performing a close approach to Jupiter in March. And so it's going to be interacting with Jupiter directly and also with its dust and plasma and gas cloud stream, because that's going to be at its densest around 3i Atlas. But at the same time, we're going to be interacting with the remnant trail of this. So we have a dust storm potentially coming in March and April of this year. And it's really interesting when you research more into it. I've been wanting to make this video for a while. I'm going to do my best to present all the different ideas, but I may, I'll definitely be releasing more information on this across time because there's a lot to this. I'll do my best to go through it. But here we see 3i Atlas on March 22nd. It's actually going to be at its closest to Jupiter on the 17th. So we can check that out by zooming over to Jupiter here. And it gets within about 0.2 astronomical units, which, as some of you may know, is right outside the Hill radius for Jupiter, which is the zone of gravitational dominance for Jupiter. And it has different moons. Jupiter has dozens and dozens and dozens of moons that have more irregular orbits. Some of them go further out. And so 3i Atlas will be passing pretty close to Jupiter. And it's carrying all this gas and dust and more. Again, we kind of have to go back to this data here processed by Tony Scarmato. And this is official Hubble data. So he effectively took the raw data from Hubble, which is coming in. And if you look here at the time, we see that it goes from the 30th of November to 27th of December 2025. And if you click, for example, this one, you'll get this preview graphic. So this shows you what the basic image that Hubble got of 3i Atlas, and this was on the 27th of December. And so what Tony did is he applied a special filter to it that removes circular features. Because as we can see here, for the most part, the coma around 3i Atlas is circular. But if you remove the circular features, then you can start to image these jets. And that's what he imaged. And so this is the Hubble data from November 30th. And then we see that it's quite a bit different looking on the 27th of December. This is before Earth's closest approach. This is after Earth's closest approach. And so we see that there was this equalization between the jets. 3i Atlas has basically just been rotating like this and just spewing stuff out everywhere across the solar system. So if we go back to our Sky Live, right, and we go back in time, rather than going forward in time, we'll go back in time. Here is its approach to the inner solar system. At its close flyby of Mars, October 3rd, it's perihelion, its closest approach to the sun on the 29th. During this entire time, it's getting more and more energized by the sun. Multiple solar storms hit it. And then, it really became active. So you have to consider the physics. So this thing is moving at its perihelion at 68 kilometers per second. And at Jupiter, it's going to be 66 kilometers per second or so. All those particles being emitted from 3i Atlas are traveling at that velocity initially, okay? If they're jetted out, now that's a new vector of velocity that adds or subtracts to the original, but the original velocity vector is that of the main host object, which is 3i Atlas, which is headed out of the solar system, and it's not coming back as far as we know. But if something is jetted off a sufficient amount, right, and it's at a right angle, let's say, it could jet off this way and also this way, and then it still has this momentum going that direction. Maybe it's jetted off that direction. Well, now it's an oppositional velocity vector. So it's going to have a slower velocity than it would have if it had just been ejected that way. If the jet ejected it this way, maybe it's even going faster than 3I Atlas. Well, 3I Atlas had this sunward facing tail, it still does. Some of the stuff has been ejected against its standard velocity vector of motion, meaning that it's going slower than 3I Atlas. If it goes slow enough, it can actually enter into a circular orbit. Now, is that possible? Like, is this jetting action strong enough to do that? That's an unknown. But because you have this perpendicular and also oppositional jetting, some of this stuff is going to be expanding out and going slower than 3I Atlas is itself. So if we go forward in time once more, we'll see that Earth then passes into that zone where some of this stuff is going to be going perpendicular and also slower. Well, you have something called the Poynting-Robertson effect. And what that is that solar radiative pressure from the sun pushes dust grains away of a small enough size. Whereas if there's a grain, whatever it's made out of, silicates, let's say like hydrous materials, water, ice, right? Low density, maybe even they're metallic, so the density is much higher, 7.8 grams per centimeter cubed, let's say. Water is 1 gram per centimeter cubed. They have different distances and sizes where the force will equal the gravitational force, so they'll stay in position, but if they have this outgoing velocity, then they'll shoot out. The small enough ones will get pushed out by the radiative light of the sun. So just the light itself can push these smaller grains out, especially the closer in they are, then the stronger that force is. It drops off inverse square. And then some grains are going to be large enough that that radiative effect isn't that strong, and they will actually spiral into the sun. Now, if they don't have that much difference in their velocity relative to the solar system, they will spiral in. If they do have a lot of difference in their velocity relative to the solar system, like 3I Atlas, then it'll be a one-time pass. So it's looking like we're going to have a one-time pass of this gas, dust, and plasma passing by the Earth. How much is going to interact with us is a big question because it depends on how much it's spread out. If it really spread out like a shotgun, then we could get hit with something. If it doesn't spread out that much, then we could just see some very minor effects because there's going to be a whole distribution across the size of the grains, their composition, whether they're more metallic, whether more silicate, whether they're more hydrous, let's say, made up of volatiles like CO2, methane, others. So there's going to be this huge distribution across all these different characteristics, density, size, again. What is the dominant faction? Well, we know that there's a tremendous amount of nickel in the coma of 3I Atlas. And so I think these are going to be a lot of metallic grains. And as a result of that, if there is enough of a draw inwards by the sun because they have enough mass and they're also large enough, then we could see them interact with the Earth in March and April, which is really interesting. Now we know that there is dust throughout the solar system. Here we see it on Saturn. Saturn has these huge rings made up of dust grains and pebbles and tiny little rocks and more. So Saturn's held on to this stuff. And we also have zodiacal dust. We can see that very clearly. Here we see a nice multi-composite image of the night sky with the constellations. And see this this faint glow, that's the zodiacal glow, that is interplanetary dust. So if someone tells you all the dust that's being emitted from 3I Atlas is going to get pushed away from the sun, they're wrong, because we have the Poynting-Robertson effect, which tells us otherwise. So we can learn a little bit more about that. And there is a Wikipedia page for it. Sometimes Wikipedia can't be trusted, you could say. They definitely skew things off from the truth often. So you have to be smart when you use Wikipedia for information. And the same can be said for anything that's based off of large language models. But I did input some of the base characteristics for this stuff, these dust grains are going to be emitted from 3i Atlas into Google Gemini. And because the velocity of them is so much different than the normal zodiacal velocity, right? The velocity of everything relative in our solar system, it's going to have unique dynamics. And the solar wind affects this as well. The interesting thing is that dust grains, they hold onto charge. So when you have a dust grain in space, it will accumulate a charge. If it's being hit by sunlight all the time, that charge can go up to hundreds or even thousands of volts. If it's in darkness, then the voltage drops just 1 or 2. It's more electron based. Whereas it'll form positive voltages if sunlight is hitting them. Well, we know that there's going to be a ton of sunlight hitting these dust grains because they're getting close to the sun. They're all there at that, in between Earth and Mars orbit. So they're highly charged, which means they form electrostatic bundles. So they don't have to just necessarily disperse out. We don't have all the physics for this. So if we get these electrostatic bundles to exist with 3i Atlas and its dust grains, then we could be hit by one or more of those. I don't know if it's a big cloud, whether it's a whole bunch of tiny ones. Like, we don't exactly know. But the calculations effectively suggest that this is going to be a one-time pass through the solar system because the relative velocity is quite a bit higher than what it is for the rest of the solar system, but we are likely to get hit by it because we had these massive, massive jets on 3i Atlas. And we know the composition of 3i Atlas fairly well because we've done different spectroscopy observations of it. So we have different spectroscopic observations, and we know that there is water from this data. But it also here, this is the key point here, the ultraviolet data shows faint, wispy structures extending away from the coma, interpreted as dust released from the nucleus. We already knew this, but now we have even further confirmation, and even the ultraviolet data showed more finely detailed structures than we knew before. So these observations are consistent with features that we see on comets in our solar system, suggesting that this is not a transient artifact, and they're real and persistent structures, and B, that these dynamics that we've learned from regular comets likely apply to interstellar object 3i Atlas. So it appears that this electrostatic dust storm is going to be a factor in March and April. I find it very interesting that that's exactly the time that Jupiter has its closest flyby. And I really see this as representing like a interstellar download where we should really just be ready to expect the unexpected. I don't know what's going to happen from this, but I think that it could get quite dynamic. I don't expect it to be like the meteor storm of 1833. I think it would have to have gone much closer to the Earth. But don't be surprised if maybe weird things happen in our night sky or around the Earth in March and April. It's also the beginning of the zodiacal season with the spring equinox. So the March equinox, that's very interesting. And there's just a lot of different little clues that this March and April is going to be quite dynamic. I think that we could see a sudden acceleration of things and energies here on Earth as a result of this. This really being just one representation of that larger reality manifestation that is occurring at this moment in time. And we do have 3i Atlas getting very close to Jupiter. I can bring up this article here by Avi Loeb. And he did the calculations, or at least looked into it, and it's Eupheme. That's the irregular moon from Jupiter getting closest to 3i Atlas. And it's kind of interesting. he mentions how in Greek mythology, Eupheme is the spirit of praise and good omen and the granddaughter of Zeus. So that is a good sign if we are speaking about the archetypal signatures of this close approach to March. I don't think this is something to fear. We don't even know what this could be effectively nothing happens, really. Like from here on the ground, it's not like we're going to see a meteor storm. That could very well be the end result. But these energies can be very subtle. That's the thing. We know that surrounding the Earth, we have these Kortolewski clouds, which are these clouds of electrostatic dust in the orbital resonance points with the moon. So we already see these sort of electromagnetic dust characteristics in space. They're highly elusive, these clouds, but they have been observed across different organizations and groups across decades. We have very limited observations, but we do have evidence of them. And there's a lot of interesting ideas out there on the Kortolewski clouds because each single grain has a voltage and it's rotating and oscillating. And then there's not billions or trillions, but like an unimaginable amount of these. They are all connected together with their shared electric field. Some really complex dynamics emerge from that. We see with the human brain what results of all the complex neural connections that we have. It gives life to, my ability to speak to you here on camera over a live stream. We see what happens when we keep decreasing the size of chips and going to the nanometer scale, right? And the on-off, 0-1 switches, we were able to pack them more and more transistors. All of a sudden, computers can do more calculations, and now we have artificial intelligence, which can do some pretty incredible things. And so it's just simply, in some aspects, what is your size of dynamic gates, you could say, information gates. And if you have a lot of them, or like a quantum computer, right, it can be not just 0 or 1, but all the different numbers, then you can do a lot of interesting things in this reality. You become now a creator, not just a receiver. And so these Kortolewski clouds, each dust grain effectively being like a little transistor or a neuron in the brain. There's ideas out there about cosmobionts and plasmabionts and plasma consciousness, and how the Kortolewski clouds, for example, or other interstellar dust clouds or more, have a consciousness that maybe is actively guiding certain forces in the solar system. These are all ideas that you can play with, that you can research into. Robert Temple is a good place to go. His book, New Science of Heaven. So yeah, it's interesting. He also talks about the CIA and there a lot, and how they've done a lot of plasma research that is off limits. And so this whole confirm nor deny angle is interesting, because if what he wrote is true, then they probably have a really good understanding of the plasma physics around 3I Atlas, and maybe they have written some of this up in research that they're not releasing to the public. But that's where you and I come in, where we can do our own research and figure some of this stuff out ourselves. So very interesting stuff, and that is the main thing I wanted to share with you, just to be aware of this coming dust storm. I think it's quite significant. I think it's going to energetically be my camera, 1 second. There we go. I think energetically it's going to be a very volatile 2 months, March and April. So just giving you the heads up for that. And we'll do a very quick question and answer. So I'll take just 5 questions from everybody. So if you have a question, please type it in the chat and I will get to that. So thank you all for being here. I just wanted to quickly create a video on this, get some of these thoughts from my mind out to the public and for other people to run on it. And I'll be back with more information on 3I Atlas and more. I've been meaning to talk about these jet streams for a while. If we go back here, what's so interesting about this is that these grains, because they have an electromagnetic effect, they can be more clumped up than you would think in space. They're not necessarily always dispersing. And if the relative velocities are the same, before they interact with Earth's atmosphere, right, they're flying through space, all next to each other. When they have a collision, if the relative velocities are low enough, then it'll be inelastic and the orbits become more similar. So you can have this condensation within an asteroid stream where all of a sudden you get a huge burst of activity. And we've seen this time and time again where certain comet streams that we pass, there's low density zones, and we get like, our meteor showers. We have, dozens of meteor showers every single year. Sometimes they're not that spectacular. Other times they're like this, showing that there's a non-homogeneous distribution of density within these dust streams, which we see created from normal comets. Well, 3I Atlas has been spewing out stuff like crazy, more so than most comets. It's created one of its own. It is headed out of the solar system because it's hyperbolic, but some of it is going to expand out and slow down, which leads me to believe that some of it will interact with the Earth. And because there's electromagnetic dynamics, especially electrostatic dynamics involved, it could be quite charged up because all those dust grains accumulate a charge. They start to hold a structure and cohesive property to themselves. It becomes a complex dusty plasma, and while we could get hit by a whole bunch of complex dusty plasmoids in March and April. So yeah, let me take just a few questions, and then I'm going to sign off. You can follow me for more intermittent updates in between videos on Twitter X, which is at Stefan Burns Geo. And Nana is asking, could such particle streams and plasma interact with Jupiter to be a big bang effect and create life there? Maybe not necessarily life or a big bang effect, but if you did have a big enough burst of ionization, it could be very interesting. I've been thinking about this recently, more than the past few days. And that's the thing. These particle streams, if they fall into a massive object, like let's say Jupiter or the Earth, as they accelerate and reach higher velocities, they then, ionize and turn into plasma. Just as something that's falling into the sun eventually will ionize and turn into plasma, unless it has a huge core and some of that can pierce even deeper in. But eventually it all becomes plasma because it gets all ionized. So that's going to happen with these particle streams. And so it's the E equals mc squared equation. Energy equals mass to the speed of light squared. So if it's traveling faster and faster, the energy goes way up. So you could have these dust grains, and yeah, their overall mass isn't that much, let's say, but they interact with Earth or Jupiter at a critical velocity, and then they're further accelerated. We could get a significant ionization event from that. Does that create a geomagnetic storm? How does that affect the plasmasphere? The telluric currents of the Earth? These are all good questions. I don't have the answer for you, but these dynamics exist. And a follow-up from Nick is, what effect might the cloud dust plasma have on satellites? Could this cause Kessler syndrome? That's a great point. There's already a lot of drag where most of these satellites are in low Earth orbit. And they're actually now moving a lot of Starlink satellites down even closer to the surface of the Earth where the drag is going to be greater. So if you do, let's say, get this dust storm to create a sudden increase in ionization and therefore drag, just like what happens during a solar storm impact, but this time it's totally out of the blue and maybe its dynamics are totally different because these grains are mostly probably nickel, right? We know that nickel is super enhanced in 3I Atlas. So you get these high density metallic grains, which are metallic and magnetic and also electrostatic. It's a really good question. We don't know, but we could see satellite problems around that time. And if we get enough satellites to fail and start bumping each other, we have so many up there now that the Kessler effect, the Kessler syndrome could go into effect where it creates this exponential rise and increase in space debris because it's like a chain reaction. So yeah, great question. I don't think we can rule it out. I think the most likely possibility is that we're actually not going to see much happening in March or April. Nothing like this. But I think it will definitely, at a minimum, my thoughts and belief is that it's going to interact with us at an energetic level and bring about some really unexpected developments and results, and just kind of like new manifestations really quickly into the public, societally, culturally, everything. But it could have more real world, like uh, tangible effects too, where it's less abstract and maybe through multiple deviations that then manifest. That's sometimes how things work under the surface, right? It could perhaps cause satellite issues. We don't know. And from Logatha, will Earth's magnetic field pull the dust towards us? Yeah, so we have to consider that aspect as well. Earth has a magnetic field, and if it's electrostatically charged, these dust grains, the moment they're following the force of electromagnetism versus gravity, it's a lot more, there's a lot more power effectively at their disposal. So if they latch onto a magnetic field, they'll stick into that or even flow down that magnetic field where it gets stronger and stronger, just like something flowing into a gravitational field, like a black hole, right? So it's certainly possible that if things get close enough to Earth, that we could even like pull them in and attract them. It's hard to say. It depends on the electromagnetic characteristics of the dust grains, whether they do form these electrostatic clumps or not. They may be too dispersed and too large to do that effectively. We don't know. But these are possibilities that we should be aware of. And no one's really talking about them, which is why I wanted to mention it. And from Jody Mitchell, has the Earth not seen dust such as this already in its history? Yeah, we have the interplanetary dust, and we do have times where Earth has passed through these sort of dust streams. Notably, back with the Black Death, we had just passed through the dust stream of a comet. And so it is discussed in some circles about how perhaps all that stuff being released from the comet, because, you know, 3I Atlas is a lot of cyanide, right? What is this material? What are the novel compounds? Maybe even one of the organics or bacteria. Like, we don't know. Like, how does that interact with the Earth? So this isn't such a close pass through the orbit and tail of 3I Atlas, I think, for us to be concerned about that in a very serious way, but that has happened in the past. You can go on Frank Hoogerbeat's website, ssgeos.org, and he has an article on that. It's a recent blog post that he did. So go check that out and read about it. It's really good. I'll link in the video description once the live stream is done. Now I'll take one more question. And from Steven with a brilliant idea. I still think it would be a good idea for us to send a small probe up with cells made from aerogel to collect samples. It has been done before with other objects. That's a good one. We should be as creative as possible in figuring out ways to get data on 3I Atlas. It's only the third ever interstellar object. We saw one in 2017 with the Oumuamua, 2019 with 2I Borisov, 2025 with 3I Atlas. But maybe we don't see one for 50 years. Maybe we start seeing a whole bunch more. We don't know. But it's basically we have to treat each single one of these interstellar objects as a one-off chance to get critical scientific data. We should be doing everything in our ability to do that. They did not send the Juno probe around Jupiter to do a rendezvous with 3I Atlas as best as possible. That was a mistake, in my opinion. That's a brilliant idea that you suggested. Ideally, we're getting regular sampling missions actually every month or every 5-6 months of our interstellar dust environment. So then we had a longer term data set to examine, and maybe we would see a unique bump in the distribution of chemistry and size and density of these dust grains when we pass through this remnant trajectory of 3I Atlas in March and April. We don't have enough data to know. That's the problem. If we did a one-off, it would be informative and help us learn more about the composition if we collected any particles. But if we had regular sampling missions, let's say every 6 months, then we could be a lot more informed with that. So the key with a lot of this stuff as it relates to understanding our solar system is doing regular observational monitoring. And then we are well aware, we're prepared when something happens because we got the systems online. We don't have our telescopes just around Earth. We have a Hubble on Mars. So when it's on the other side, we're still getting good imagery, right? We have more stereo probes around the sun. So we're not just tracking sunspots on the Earth-facing side, but we're getting a more holistic view of sunspots across the entire solar disk for the solar cycle. Because we're making these assessments off of the intensity of the solar cycle based off of just Earth-facing sunspots. That's neglecting half the Earth, half the sun. So there's a lot of limitations with our current space science, though a lot of us think that space science is like holier than thou, and that we can't get any more advanced or better, and our understanding of the universe and cosmos is perfect. Far from it. We know very, very little. So yeah, we should be doing more tests and missions like that, or whatever the most intelligent one would be, but we should be doing them more consistently. That is what I would argue. I don't think we probably have the budgets for it, but they're also wasting a lot of money. So yeah, there's a lot of things there. But that is it for today's video. Thank you all so much for watching, everyone. I hope you found this informative and valuable. I'll be back with more information as I do more research into this. I do think that we are going to be having some gas, dust, and plasma from 3I Atlas interact with Earth in March, the same time that Jupiter has its closest approach. There's clearly a Earth-Jupiter resonance there as well. And I think that it may end up being transformative for us here on Earth, societally, individually, collectively. It's going to be hard to say, but we are much more connected to not only our local environment, but the entire cosmos than most people think. It really is incredible. I recommend you go out there and connect to the cosmos yourself. We have an incredible planetary alignment happening right now with Mars and Venus conjunct, also conjunct the Sun, Jupiter in opposition, and a Saturn-Neptune conjunction in the sky right now. So, and with 3I Atlas nearby us, now more than ever, we are having these interstellar cosmic energies oscillate and vibrate across our entire solar system, which in many ways is like a standing wave of energy. And how does that affect us? Well, we're already seeing the effects here on Earth. So I will keep you up to date. Thank you all so much for watching. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.